Okay, so in this video I'm going to be talking about cathode rays. When I was talking about the cathode ray oscilloscope, you heard me mention a lot of things concerning cathode rays. There were some properties which I had even given concerning cathode rays and all that, how they propagate, how they move in the CRO. We at least tried to give ourselves an idea concerning those things. So in this video, what I'm just basically going to do, I'm just going to talk about these cathode rays individually now. Okay, I want to explain them in depth and give much more guidelines concerning them. Okay, so cathode rays, these are just streams of electrons that are released from a heated metal surface. Okay, so these are just streams of electrons which are just emitted from a heated metal surface. If you don't want to use the word released, you can use the word emitted. Okay, they just mean one and the same thing. Released from a heated metal surface. So if this is a given metallic surface, and then electrons are just residing there. In chemistry, you hear me talk about bonding. I'll be talking about the kinds of bonds that we have, ionic bonding, covalent bonding, and of course ionic bonding, metallic bonding, and also this covalent bonding. So the kind of bonding which is found in metals, as we all know, is just metallic bonding, and metallic bonding is characterized by delocalized electrons. You're going to see that we have some things which we call delocalized electrons. There are some electrons which are able to move around those same metals, and it is because of these same delocalized electrons that makes these metals to be good conductors of not only just heat but also electricity. So it's very much important. Metals are characterized by what? By metallic bonding. Under metallic bonding, you're going to see that there will be an involvement of delocalized electrons. There'll be an electron pool, okay, an electron pool, an electron density that is just going to be around the metal particles. And these electrons, like I have just said, are what makes these metals to not only just be good conductors of heat but also good conductors of electricity. So what is going to happen now is that when heat has been introduced, what is going to happen is that these electrons now will begin to gain kinetic energy. Okay, these electrons will gain kinetic energy, and once these electrons gain kinetic energy, one thing that you need to understand is that they will gain a lot of kinetic energy, yes, that is going to make them to be released from that heated metallic surface. Okay, when they are heated, they will gain sufficient kinetic energy that is going to make them released from that heated metallic surface. Okay, that heated metallic surface. This phenomenon is very much important to know and understand. This emission, this releasing of electrons, okay, this emission, this releasing of electrons from a heated metallic surface is what is referred to as thermionic emission. This releasing of electrons from a heated metallic surface is what is referred to as thermionic emission. Okay, this is what is referred to as thermionic emission. The other name for thermionic emission is termed as the Edison effect. Okay, the other term given to thermionic emission is known as the Edison effect. It was brought about by a man by the name of Thomas Edison, okay, by a man known as Thomas Edison, and this was in 1883. So in 1883, Thomas Edison was the one who observed this effect, this let me just say phenomenon that was taking place here. Okay, so these cathode rays are released from a heated metal surface by a process referred to as thermionic emission, or the Edison effect. Why Edison? Because the founder, the person who observed all of this, was termed as Thomas Edison. That was his name. Okay, that was his name. His name was Thomas Edison. So in the next video, or in one of these videos, I'll tend to explain in depth thermionic emission, even the equations that are involved there. But for now, let's just stick closely to these cathode rays. Now, I had mentioned in the previous video, when I was talking about the cathode ray oscilloscope, I told you to say that cathode rays should not be mistaken for beta rays or beta particles. Beta rays or beta particles, these are streams of electrons that are released from the nucleus of a radioactive substance. So cathode rays are not beta rays, they are not beta particles. Cathode rays are streams of electrons that are released from a heated metal surface. They gain enough sufficient kinetic energy to be released from that metallic surface. Beta rays or beta particles, these are streams of electrons that are released from the nucleus of a radioactive substance. That should be in your mind. Now, what are some of the properties of cathode rays that we should be familiar with? What are some of the properties of cathode rays that we should be acquainted with? Well, like I've said, so let's look at the properties. Let us look at the properties. Well, cathode rays, these are just streams of electrons. That's the first property that you can give. They are streams of electrons. Okay? They're streams of electrons. The other property that you can give under the other property for cathode rays that you can give is that they're not only just streams of electrons. Remember, they are negatively charged. They are negatively charged. Apart from being negatively charged, one thing that you need to know is that these cathode rays also move in straight lines. They move in straight lines. They move in straight lines. Apart from moving in straight lines, the other thing that you need to know is that these cathode rays possess kinetic energy. They possess kinetic energy. They possess kinetic energy. Because they are moving. And remember, under physics, any object that is in motion possesses kinetic energy. So these things possess kinetic energy. So they're streams of electrons. They are negatively charged. They move in straight lines. They possess kinetic energy. The other thing that we can see is this. When we were talking about the cathode ray oscilloscope, we said that anytime these cathode rays, these electrons, are moving into the deflection system, we saw that there were some Y plates and there were some X plates. Now, these Y plates, these X plates, there is a certain electrostatic field that they introduce. Okay, there is a certain electrostatic field which they introduce, an alternating electrostatic field which they introduce, and this is what is going to be causing these electrons to be moving vertically and also horizontally when they pass through firstly the Y plates and then secondly the X plates. There is an alternate electrostatic field or electric field that they generate. Okay, So basically the whole point is this: these cathode rays are deflected. They are deflected. That is, they are dispositioned. They are deflected by electric and magnetic fields. But let me put electric fields first. They are deflected by electric fields. Like we had seen, the Y plates were deflecting these cathode rays vertically, while the X plates were deflecting these cathode rays horizontally. Okay, so they're deflected by electric fields. And then lastly, what we can do is that we can also say that they are deflected. They're deflected by magnetic fields. They're deflected by magnetic fields. Electric fields and magnetic fields are two different things. Electric fields and magnetic fields are two different things. Okay, so they are deflected by electric fields and they are deflected by magnetic fields. So this is what we can say about cathode rays. Well, an extra thing that I can give is this one. We say that these are streams of electrons. Now take note, these are electrons which are delocalized. Okay, these are electrons which are delocalized. So those delocalized electrons are the ones which are released, are the ones which are emitted. So I want to emphasize one point though. Electrons are one of the subatomic particles which are found in an atom. They are mostly found in the shells or orbitals of a given atom. Protons and neutrons are fixated in the nucleus of an atom. Every chemical reaction that takes place mostly involves electrons. Okay? Every chemical reaction that takes place mostly involves electrons. So what I wanted to say or to add on is that the actual mass of an electron is 9.11 times 10 to the power negative 31 kg. The relative mass of an electron is just 1 over 1840. Don't forget this. There is a big difference between the actual mass and the relative mass. You hear me explain this more in chemistry, but I just thought of putting it here. The actual mass of an electron is 9.11 times 10 to the power negative 31 kg, and its relative mass is 1 over 1840. Okay, 1 over 1840. What this means is that the mass of an electron is about 1840 times smaller than a proton. This is what it means. The mass of an electron is about 1840 times smaller than a proton. Okay, so don't forget this. Actual mass 9.11 times 10 to the power negative 31 kg. The relative mass 1 over 1840. So this is what I can say in this video concerning cathode rays. But in my other video I'm going to explain the thermionic emission or the Edison effect in much more depth. So thank you very much.